Hello everybody, this is my poster presentation, Characterization and Gas Sensing Behavior of Zirconium Oxide Pellets in Carbon Monoxide Environments. This is my experimental section. First, I prepared two different solutions. The first one was the zirconium precursor solution, and the second one was an ethylenediamine solution. I use ethylenediamine as a chelating agent in order to control the morphology of the final product. First, the two solutions were mixed together, and the final solution was kept under magnetic stirring for 24 hours, and then the solvent of the final solution was evaporated by using microwave radiation, and the obtained paste was dried and calcined at different temperatures in order to obtain the zirconium oxide powders. In order to study the gas sensing properties of the materials, pellets were fabricated and ohmic contacts were applied on the surface of that pellets in order to enable accurate electrical measurements. The samples were characterized by XRD, CEM, and UVVs. The XRD results shows that the material crystallized in alpha phase at 800 and 700 degrees Celsius, but I worked only with the samples calcined at 700 degrees Celsius. The CEM results shows a surface composed of spherical particles with an average particle size of 33 nanometers. And UV's results revealed a band gap value of 3.5 electron volts. That is a value suitable for gas sensing application. For gas sensing test, the pellet was put on a heater inside this vacuum chamber, and in this vacuum chamber we control the gas concentration by controlling the pressure inside the chamber, and the electric and resistance change of the pellet was recorded by using a multimeter. And this is my gas sensing results. This is the plot of response against concentration. As it can be seen, the maximum response was obtained at 300 degrees Celsius at 500 ppm. However, we obtained a good response at 200 degrees Celsius, indicating an effective detection at low temperatures. This suggests potential for practical application in environmental monitoring and safety. So that's it, and thank you.